Section 7.2, Negative Rational Exponents. If you recall, when you have something raised to a negative exponential power, we can eliminate the negative exponent by taking it to the denominator. And we'll see that we can do that with negative rational exponents as well. Here we have a raised to the negative m over n means that's the same as 1 over a to the m over n power. To eliminate that negative exponent, we took the term to the denominator. Also, before we look at some problems, let's review the law of exponents that we have. When you are multiplying common bases together, you add the exponential powers. When you have common bases that are divided, we subtract the exponents. So an equivalent here would be a to the m minus n. When we have a base raising a power to a power, you multiply your exponents. So an equivalent expression would be a to the m times n power. If we have a product raised to a power, you will raise each factor to the power and multiply. So this equivalent expression to this one would be a to the n times b to the n. So let's take a look at simplifying problems that have negative exponents in them. And they're asking us to write with positive exponents and simplify. So first off, to get rid of the negative exponent, we will drop this to the denominator. So we'll have 1 over 16 to the 1/4. And then to replace the rational exponent, we will use the denominator as our index on the radical. So we're taking the 4th root of 16. And since 2 to the 4th power is 16, this radical and term simplifies to 1/2. In the next problem, we have a negative exponent. So to eliminate the negative exponent, we'll take the term to the denominator. Next, to simplify it, replace the rational exponent with the equivalent radical. This is equivalent to asking us what is the square root of x, but in the denominator. Since we don't know any value for x, we'll leave this as our solution. There is sometimes proper form of simplifying the denominator that has a radical in it. We call this rationalizing the denominator, and we'll talk about that later. For right now, we'll leave it as is. In this next example, we have a denominator with a negative exponential power. So to eliminate a negative exponent in the denominator, it will come to the numerator. So this is equivalent to x to the 3/4 power. As far as simplifying this, we can put it in radical form, but since this fraction cannot be reduced any further, we won't be able to simplify the radical either. And just to show you what that means, remember the denominator is our index. We're taking the 4th root of x to the 3rd power. We only have 3 x's multiplied together here. It's not large enough to take the 4th root. We're looking for 4 of a kind, and we only have 3 of a kind. So this would be fine for a simplified answer. Only if the directions said in radical form would we take it a step further. In the next problem, we have a term that does have negative exponents in it. And to get rid of those negative exponents, slow this down a little bit, it's only the y that has the negative exponent in it. The 3 is fine, it's to the 1st power. The x to the 4th power is fine, but we will take this term to the denominator. These are all multiplied together to make it positive. So it will be y to the 1/3 power. There's nothing to simplify until we know values of x and y, so our answer is complete. They're asking us to take this fraction to the negative 2/3 power, which we had a property when we went through the law of exponents earlier in this course, that when you're taking a fraction or a rational number to a negative, we can invert the fraction to have an equivalent expression and eliminate our negative exponent. That leaves us with taking 8 to the second power and the cube root of it. Taking the cube root makes more sense since 8 is a perfect cube, and then raising it to the second power. The cube root of 8 is 2, since 2 times 2 times 2 is 8, and then squaring it gives us a final answer of 4. Just to show you how this property works as a shortcut, we have a fraction raised to a fractional power, means 1 is to the negative 2/3 power, and the denominator is 8 to the negative 2/3 power. We don't want negative exponents. To eliminate the negative exponent in the denominator, it will go down to from the numerator to the denominator. And to eliminate the negative exponent in the denominator, it will go to the numerator. The cube root of 1 is 1. 1 squared is 1, leaving us with 8 to the 2/3 power, which we just simplified up here. In this last one, they want us to write with positive exponents, and we have a radical. So first things, we want to get rid of the radical, and the translation of the cube root of a would be a to the 1/3 power. The index becomes the denominator of our exponent, and as it turns out, it's in the denominator, and there are no negative exponents in this problem, so we have simplified this and have all of our variables with positive exponents. A couple more examples. Here we have common bases with a division, which means we will subtract our exponents. We will have 3/4 minus 1/4. Good news, we have common denominators, so we can subtract the numerators. 3 minus 1 leaves us with 2/4. And anytime you're working with a rational expression and can reduce, by all means do that. So we ended up with y is equal to 1/2 as a simplified rational exponent form. In the next problem, we have a power raised to a power, which means we will multiply those exponents. So we have 2/3 times 25, which has a denominator of 1, and it leaves us with 2 times 25, which means x will be to the 50th power over 3 times 1, or 3. Typically, we will leave our exponential power as an improper fraction rather than a mixed number. Perhaps they would list this as a decimal equivalency, but having that third isn't going to give us an exact decimal equivalency other than putting a repeat bar. 50 over 3 is the best way of expressing this. In this last example, we have a product raised to a power, which means each of those factors is raised to the power. 5 is raised to the third power. X to the 1/7 is raised to the third power. And furthermore, y to the 5/7 is raised to the third power. 5 to the third power is 125. 3 has a denominator of 1. 1/7 times 3 leaves us with x to the 3/7. And again, 3 over 1, 5 sevenths times 3 is going to leave us with y to the 3 times 5, or 15 sevenths, for the simplification of this problem.